Hello class, welcome to lesson 5. This is equation and graphs. Equations, not equation. Objective is I can translate between equations and graphs by using input-output tables. Our vocab word is linear equation, an equation whose solution from a straight line on the coordinate plane. Any point on the line is the solution. Alright, so it's important to remember that ordered pairs can be the solution to an equation. So for example, if we looked at 2 and 5, and we had the equation y equals x plus 3, our 2 could be our x, and our 5 is our y, because remember, an ordered pair is x, y. So then it would be 5 equals 2 plus 3. See how that works? So let's see how that plays an effect on our graphs. So I need to graph the linear equation. So this is my linear equation. I need to graph that. So I'm going to make an input-output table. This one's going to be a bit longer. So I'm going to have my x and my... Usually I just have an x and my y. I'm going to put my rule and my y. So if I do this, let's say I plug in, just like when we created our ordered pairs, our equations from our input-output tables, I'm just going to choose a set of numbers to plug in. And I'm going to plug those into my rule, which my rule is 3x. So I have 3 times 1, which my y would then be, the answer to that, it would be 3. So next it would be 3 times 2, and my answer of that is 6. Then I have 3 times 3, which the answer is 9, and 3 times 4, which my answer is 12. So now if I were to make ordered pairs, which is x and y, it would be 1, 3, 2, 6, 3, 9, and 4, 12. Now I need to graph that. I made kind of a bad table here, but we're going to use it. Alright, now I can draw my line through this. So when I graph this linear equation, this is what it looks like. And that is my final answer. Let's see how that works. Let's see some steps. Alright, step 1 is to create an input-output table for the linear equation. So I have some extra little side steps here. So we have step 1a and step 1b. So to create your input-output table, we need to find our x and our y. And you can choose any 3 numbers to be your x, and then you will use your x to find your y. So let's say I choose 1, 2, 3, 4, 5. Now I'm going to plug in these x's into my equation. So it's y equals 3x. So it'll be 3 times 1, which would give me 3. So that is my first y. Then it would be y equals 3 times 2, which gives me 6, and that's my second y. And I will continue with that to find all my y's. All right, now that's how you create your input-output tables. Then you need to graph for x and y. So basically, when you're graphing x and y, you're creating coordinate pairs and you're graphing that. So our first coordinate pair would be, we could even just put parentheses around here, 1 and 3. Let's finish making our graph first. All right, so I have 1 and 3 is my first ordered pair, so 1 and 3 is here. Then I have 2 and 6. Then I have 3 and 9. Then I have 4 and 12, and I didn't feel like making everything because I just had to have a minimum of 3. And that is my linear equation graphed. Notice that it doesn't have to go directly to 0. It can just reach the line here. All right, let's do some examples. All right, so I'm going to start by making my table. So I need to graph the relationship. And I have y equals x minus 2. So let's say, I don't even need a graph this big. What is a table this big? I'm just going to do 1, 2, and 3. Easy peasy. Then it'd be y equals, oh, look at here. Make sure you do something that's going to make sense. If I plug 1 in here, I'm going to have 1 minus 2, which gives me negative 1. So we got to make sure that the numbers we choose are easy to use in our equation. So let's use 4, 6, 9 instead. So then it would be y equals 4 minus 2, which is 6. So y is 6. And when I plug in 6, 6 minus 2 equals 4. And then I have y equals 9 minus 2, which would equal 7. All right, now I'm going to graph 4 and 6. So crawl to 4 and walk to 6. Next, I'm going to do 6 and 7. 6 and 7, 6 and 4. Go over to 6, up to 4. And then finally, I have 9 and 7. So go over to 9. I messed up. Aha! Did you guys catch that silly mistake? I did 4 minus 2 equals 6. What? That doesn't make sense. That's 4 plus 2. I should have a 2 here. That's why that doesn't make sense. So then I have 4. So I go to 4 and up to 2. There we go. And then I go to 9 up to 7, which happens to be directly on here. So let's move this. So 9 and up to 7, which is here. Now I'm going to draw my line. That is my linear equation. Let's try another one. So here we have y equals 2x. I'm going to start by creating my input-output table. And I'm going to do, here it works if it's multiplication, so I could just do 1, 2, 3. So y equals 2x, where 2 equals 1. 2 times 1 is 1. That's a lot. 2 times 1 is 2. Y equals 2 times 2, which is 4. And y equals 2 times 3, which is 6. So here's how I got this 2. Here's how I got this 4. And here's how I got this 6. My first ordered pair is 1 and 2. So go over to 1, up to 2. Next is 2 and 4. 2 to 4. And finally, I have 3 to 6. Now I'm going to draw a line through that. And that's my linear equation. Alright, for this, you are given a graph and have to find the linear equation. So we need to look at, so we have 0, which starts at 1. So our first coordinate pair is 0, 1. Our next coordinate pair is 1 and 2. Then we go over to 2, it goes up to 3. Then we go to 3, it goes up to, our y is 4. 4 goes to 5. 5 is basically on 6. And then finally 7 is around 8. Pardon my not the best straight line drawing skills. So now I have to look at the relationship. So I need to look at what's the increase between these y's. What are the differences happening there? So it's going to be y equals something. So we will answer this when we meet in our designated meeting time. What do you think the linear equation would be? How are these increasing? I'll see you guys then. Homework will be posted at 8:30. Bye, guys.